What's up, guys? Social Looks Math here, and today I'm solving 12 of the hardest digital SAT math questions that appeared on the June digital SAT. And this is my first long form video, so if you guys enjoy the video, please like, drop a comment, subscribe, and give me any feedback. I'm open to any feedback to make these videos better and more enjoyable so that you guys can learn better. Okay, so let's get into the first question. Okay, let me erase this real quick. So the first question reads that in the figure, parallel lines R and S are intersected by lines T, U, and W. If D is equal to 67, G is equal to 118, and H is greater than D, which statement about J and P must be true? So what we're going to do first is we're just going to find the value of P first, okay? So the first thing I notice is that I see an angle D here, and I know that this angle must also be angle D because these angles are vertically opposite, and vertically opposite angles are equal. So since D is equal to 67, which was given in the problem, that means this angle is also going to be 67. Next, I see that angle G and this angle right here both must add up to 180 because they're collinear. They lie on the same line and they're intersected by a transversal, which is the line R. So that means that this value must be 180 minus G, and G was given in the problem as 118. So if I do 180 minus 118, I get the value of this angle as 62. Okay, if I know that this is 62 and this is 67, I can find the value of P because this angle is also going to be angle P because these two angles are vertically opposite. So that means they must be equal. So that means this is also P. So then you can see that this forms a triangle right here, where these three are like these three angles are the angles of the triangle. So I know that 62 plus 67 plus P must be equal to 180. So that means P is equal to 51. So I'm just going to say P is equal to 51 right there. Okay, now let's solve for angle J. And the way we're going to do that is by first assuming a value for H such that it satisfies the inequality given in the problem. So if D is 67, what we can do is we can imagine H as 68. Okay, just one measure ahead of that. Okay, and now let's solve for angle J. So first what I notice is that if this is angle H, that means this is also angle H because these angles are corresponding angles and corresponding angles are equal. So H, this basically is going to be 68. And then I also know that this angle is 62 based on what we solved because G plus this angle right here must be added to 180. So if I do 68 plus 62, and I also know that the top angle of the triangle, this triangle right here, the top angle of it, that's also J. That is J because they're vertically opposite angles. So that means in the triangle, I have this angle, which is 68. I have this angle, which is 62. I have this angle, which is J. So then I can say that 68 plus 62 plus J is equal to 180. And I get J is 50. Okay. So let's just take a, oh, instead of saying 68, I'm going to say H. Okay. So let's just take a look at what happens if I simulate random values for H such that it satisfies this inequality. So right now you can see that 51, which is P, that's obviously greater than J. Okay, if I increase the value of H, which I have to do, right, because H must be greater than D, where D is 67. Let me make this 67. If I increase the value, look what happens to the value of J. The value of J will decrease no matter what, and it just will because then H needs to satisfy this inequality. So the value of J will decrease such that J is less than P. So no matter what value of H we choose, J is always going to be less than P. So this ends up making D our correct answer to this question. Okay, let's move on to question 13, which is the infamous sweater question, the word problem question that a lot of people had on their forum. So the question reads, an online store is offering two different discounts on its sweaters, a bulk discount for large orders and a coupon discount. For orders of N sweaters where 10 is less than N, which is less than 50, a bulk discount of N% off of the original price of $43 is applied to the price of each sweater. If a coupon is applied to the order, a discount of an additional $2 is applied to the price of each sweater after the bulk discount is applied. For a certain order with both the bulk discount and the coupon discount applied, the total price after the discounts for the sweaters purchased was $648. How many sweaters were purchased in this order? Okay, so we need to find basically the value of n. So this problem I like to take one step at a time. So I have an original price of $43 and I'm taking n% off of that. So let's just use what we know. We know that if the original price is 43 and we're taking n% off of something, that's basically 1 minus n%, and n% is n over 100. So this will give me the price with the bulk discount applied. Okay, and what we need to do now is we need to add the coupon discount on top of this. And the way we do that is by subtracting 2, right? Because that's for each sweater. And now, since this is the discount, which includes both the bulk discount and the coupon discount per sweater, if we want to find it for n sweaters, we multiply by n. And then we know that the total price is 648. So I just do tilde 648. And I get my value for n is 20, so C is my correct answer to this question. So you just have to take this one step at a time. This is the bulk discount. We then subtract 2 for the coupon discount, and then this will give us the basically the price for for one sweater, and then we multiply by n to find it for n sweaters. We do tilde 648, and then we get n as 20. So C is our correct answer to the question. Okay, let's take a look at this question. Question 15. This is a statistics question. The longest part of a finch's leg is the tarsus. A biologist studying birds measured the tarsus length of a random sample of 30 finches from a habitat. From the sample, the biologist estimated the mean tarsus length for the finches in the habitat was 19.11 millimeters, with an associated margin of error of 0.13 millimeters. The biologist will select a new random sample of 60 finches from the habitat to obtain a new estimate of the mean tarsus length for the finches in the habitat. Which of the following is most likely to be true about the margin of error for the new estimate? So we actually don't care about what the mean tarsus length is itself. Like the 19.11 is irrelevant. We only care about the margin of error. So the key here is to realize that sample size and margin of error are inversely related. So if you have a greater sample size, you're going to have a more accurate and precise measurement. So that means your margin of error is going to be inherently less. So if we know that for 30 finches, the margin of error is 0.13 millimeters, then for 60 finches, we're going to have a more precise and accurate measurement, which means our margin of error will be less than 0.13 millimeters. So that makes A our correct answer here. So in order to solve this question, all you need to know is that sample size and margin of error are inversely related. Okay, let's move on to the next question. Question 16. Okay, this is an altitude question. In triangle ABC, I'm going to draw that out. In triangle ABC, angle B is a right angle. So I'm gonna say that's B. I'm going to say A up here. I'm going to say C down here. Okay. Point D lies on AC. So I'm going to label point D right here. Such that BD, so I'm going to connect B and D, points B and D, such that BED is perpendicular to AC, and perpendicular means that we're creating a right angle. So I know that drawing is a tad bit inaccurate, but that's basically what it's supposed to look like. The length of AB is 39, so this is the length 39, and the length of BD, which is the actual altitude of the triangle, so this is an altitude, is 22 less than the length of AB. So basically 39 minus 22, 17, right? 39 minus 22, that's 17. Then it asks us what is the value of BC over AC. Okay, so there is like the College Board way of solving this problem is by doing similar triangles, and you basically have 3 similar triangles here. You have triangle ABD, you have triangle BDC, and then you have the big triangle ABC. So personally, I never enjoy doing similar triangles. For me, it's like really hard to keep track of what side like matches which side and what angle matches which angle in all the triangles. So it's really complex for me. So the way I like to approach this problem is by brute forcing it, like actually solving for the values of BC, AD, DC, and all these side lengths. And the way you do that is by knowing the geometric mean altitude formulas. I think that's what it's called. Geometric mean altitude formulas. So yeah, it's basically this formula right here. So we have the length of the altitude, which is 17, as given to us. That's equal to the square root of p times q, and p times q is basically the two segments that the altitude divides into. So if we just extend this line a little bit, you're going to see that this is one segment right here, and this is the other segment. So we can say that 17 is equal to the square root of AD times DC. And lastly, there's also one more, where you can calculate the altitude of a triangle, and that's basically the product. So I'm going to say altitude, which is A, or in our case is 17. That's equal to the product of the legs of the triangle, the entire triangle. So AB times BC, so that's 39 times BC divided by the hypotenuse, which is AC. And these formulas are personally, for me, really easy to memorize, just because it's um, just like multiplying the legs, dividing that by the hypotenuse, and then square root of just the two segments. It's kind of relatively easy. But what we're going to do is we're going to make use of, we're going to try and find some sides and try and plug it into the formula and see if we can calculate the value of BC and AC and then just divide them. Okay, so first, what I notice is that I know that if this is a right angle right here, then that means this is a right angle as well. Just because if this is 90, this is 90, and then both must add up to 180. So if this is 90 degrees, we know that this basically becomes a right triangle. ABD becomes a right triangle. And we can calculate the side length of AD by using our Pythagorean theorem, because we have this leg, we're trying to solve for this leg, and this is the hypotenuse. So I can say that 17 squared plus, I'm going to say x1 squared, that's equal to 39 squared. 39 squared. And that's basically some random decimal, okay? That's basically AD. So I'm going to say AD. I don't know, I can't do that. Okay. Just keep track that x1 is 80. So this is 35.099. Okay. Now what I can do is I can solve for the length of DC using this formula right here, because I have the length of AD. So what I can do is I can plug that in. I can do 17 tilde square root of x1 times, let's do y1. I can, oh, x1 doesn't save. Okay, I'll just type it out, or I'll copy and paste it. Times y1. Okay, so that means that y1 is basically the length of DC, which is 8.23365. Okay, and now I can finally solve for this length as well by adding these two lengths together, and then just using my Pythagorean theorem. So if I do x1 plus y1, that's going to give me the hypotenuse, which is I'm going to call h, right? Because I'm doing AD plus DC. That's the entire length of AC. That's the hypotenuse of a triangle. So then what I can do is I can solve for BC by doing another Pythagorean theorem, by doing 39 squared plus this side length squared, and that's equal to h squared. So I'm going to do 39 squared plus, I'm going to say, let's do a d squared. That's equal to h squared. Oh, actually, I'll just do this squared. So d is 18.8. So I'm gonna write that here. 18.8896. Okay, so then I have my length of BC, and I also have my length of AC, which is the hypotenuse. So if I do BC over AC, BC is D, and then if I divide that by H, I'm going to get 0.43. And since I copied and pasted all the decimals, you're not going to get exact. You won't be able to convert it to a fraction. But what we can do is we can just type in each answer choice and see which one's like really similar. So if I do 17 over 56, I get 0.3. That's obviously not close. If I do 17 over 39, that is 0.435897. So this is like virtually the same exact thing. So then from there, I can say B is my correct answer to this question. So I know like this, like the way I'm doing it, seems like really complex, and you might as well just do similar triangles. But if you have these formulas down, you can honestly just do everything in decimals. Like the only reason I like wrote all the numbers down was to show you, but otherwise you could store everything into some variable and just do the easy calculations from there. But personally, I like doing it that way, by using the geometric mean altitude formulas. Okay, question 17 now. Jamie engages in up to 3 types of exercises each week for a total of 8 hours while training for a triathlon. Jamie swims for the same number of minutes each week. The equation y is equal to 480 minus x minus 120 represents the situation where Jamie bikes for x minutes during the week and runs for any remaining time y in minutes. If the equation is graphing the xy plane, which statement is the best interpretation of the x-intercept of the graph? Okay, so first what I notice is I can simplify the equation they give me. My equation becomes y is equal to 480 minus 120, that's 360, minus x. And then since we're talking about the x-intercept of the graph, right? That is basically when y is equal to 0. So if I just replace y with 0, I can add x to both sides. So then x is equal to 360. So if I look in the question where it says x minutes basically represents the amount of minutes Jamie bikes. Okay, so let's take a look at our options now. Um, During a week when Jamie doesn't bike, that's incorrect because Jamie is biking for 360 minutes. So if we look at answer choice D, he bikes for 360 minutes, and that occurs when Jamie doesn't run. And as we see in the question, he runs for any remaining time y in minutes. And we said y was 0 because the x-intercept of the graph is when y is equal to 0. So that means Jamie's basically not running. He's going to be, I mean, he's not running, he's biking for 360 minutes. So that means D is our correct answer to this question. So the first step we took was to simplify the equation they gave us in the problem by doing 480 minus 120, combining like terms. And then we realized that an x-intercept is when y is equal to 0. And if y is equal to 0, then that means we're saying that Jamie doesn't run any minutes whatsoever because he runs for any remaining time y in minutes. And if y is 0, he's running for 0 minutes. So then all we do is just simplify the equation, add x to the left-hand side, and we get x is equal to 360. So when Jamie doesn't run, he bikes for 360 minutes. So that's our correct answer to this question. Okay, let's take a look at question 20 now. Okay, another big geometry question. So a right square pyramid. Let's draw this out. I'm going to have a square base. And then I have, actually, I'm just going to search up a picture, right? Right square pyramid. Okay, this looks like a good image to use. Okay, so let's use this for our calculations. But if you want to draw like a right square pyramid, what you would do is you would draw a square base because this word square basically tells you what the base is. In a pyramid, you have just a bunch of triangles. You have 4 triangles like this. And these are all isosceles triangles because this is this, that's equivalent to that, that's equivalent to that. And then you have the base, obviously. Okay, so I'm just going to use this so that's easier to model in 3D. So the question reads, a right square pyramid has a surface area of 64 plus 16 square root 977 square inches, which includes a base area of 64 square inches. What is the height in inches of this pyramid? Okay, so what we have to realize first is that since the base is a square, and the area is 64, then that means each side length of the square is 8. So this is 8, this is 8, that one's 8, and this one's also 8. Okay. From there, we have to realize that we have 4 isosceles triangles. We have one front face, one side face, one back face, and then another side face. And we can represent the area of an isosceles triangle as 1/2 base times height. And height, in our case, is not the height of the pyramid, it's the slant height. So it's this height going up like that. Okay, and we're basically gonna calculate the value of the slant height, which is, I'm not gonna call that h. I think you guys will get confused. I'm gonna call that L, which is a slant height. So if I can basically determine a value for the surface area of the lateral faces, which is all 4 of these triangles, I can find that out since I have the total surface area. Since I know the base area is 64, I can just subtract 64 from this, which will basically remove the 64. So that means 16 square root 977 is basically the area of all 4 of the lateral faces combined. So that's basically 1/2 BL times 4. So that's what I'm going to do here. I'm going to do 1/2 B times L and then I'm multiplying all that by 4. And just notice if I multiply this by 4, then that means the 4 and 1/2 will cancel. So we're basically saying 2BL tilde 16 square root 977, and the base, the side length is basically 8, right? Because this is the base, this is the height, the slant height. So if I'm saying 2 times 8, I get the slant height as 31.257. Okay, so I know that the slant height right here, that's 31.257. Okay, now this question becomes really easy. We can solve for the height right here. So if I draw that down, you're going to notice that this will create a right angle with the base of the square pyramid. So that's why in the problem, in all the SAT questions, it tells you it's a right square pyramid, so that you know to use Pythagorean theorem, because the height will create a right angle with the base. So notice here that this entire length is 8. That means this entire length right here, that's going to be 4. That's just going to be half, right? It's going to be half of that. So then basically what I have is I have a triangle with the height 4 and then the slant height, which is 31.257. So you're going to notice that this is basically the slant height is the hypotenuse, 4 is the base. So that means you can find the height by doing Pythagorean theorem. So if I do, I'm going to say x1, which is the height, squared, plus 4 squared, that's going to be equal to L squared. I'm just going to do L. That's 31.257 squared. And you're going to see that x is 31, so the height is 31. So yeah, 31 is our answer to this question. So what you have to do first, in order to recap, is determine that the side length of this square, the base is 8 each. And then you subtract that from the total surface area in order to get the lateral surface area. And then you do 4 times the area of one of the lateral faces, which is 1/2 BL, where B is basically 8. You determine the slant height, and then you do Pythagorean theorem from there in order to determine what the height truly is. Okay, so let's move on to the next question. Okay, another very difficult question. Question 21. In triangle XYZ, the measure of angle X is 90. So I'm going to draw a triangle out right here. This is another altitude question, by the way. So I'm going to be using my formulas, but I'll run through it quick this time. So I'm going to say X, Y, C. C. Okay, I have X as 90. Point W lies on segment YZ. So segment YZ, point W. And segment WX, which I just drew, WX, that's perpendicular to segment YZ. Okay, I have another perpendicular line, like that. The length of segment WY, so where's WY? That's 732. The length of 732, and the length of WX, where's WX? The altitude, basically, that's 549. So then the question asking us, what is the value of tan z? So this is actually a one-step thing based on the formulas I gave you earlier. So we know that the altitude of the triangle, which is wx, given in the problem, that's equal to the square root of the two segments it divides. So wy times wz. Okay. So the altitude divides the hypotenuse into two segments, this segment and this segment, and that altitude is equal to the square root of the product of those two segments. So let's just plug in what we know. We know that wx is 549. That's equal to, so tilde, square root of wy, which is 732, times the product, times the length of wz. I'm just going to call that x1. So then we know that this length right here is 411.75. Okay, now this question just becomes really easy, because what we're looking for is tan z. So let's remember what tangent is. Tangent is, so for those of you who remember it like this, TOA, that's opposite over adjacent. So if we have the angle tan z right here, the side opposite to that, that's 549, and the side adjacent to it, that's 411.75. So if I just do 549 divided by 411.75, simplify the fraction, I get 4 over 3. So that means A is my correct answer to this question. So see how easy it is using these formulas rather than doing a bunch of the similarity stuff. I mean, personally, I find it a lot easier, but if you like the similar triangles way, go for it. Okay, let's take a look at question 22 now. So this question, a bunch of people had as their question 22. So points x, y, and z lie on a circle, and the measure of angle xyz is 141.9 degrees. What is the sum in degrees of measures arc x and y? So I'm just going to use a triangle feature right here. I'm going to put point x. Actually, I'm going to put point x here, y here, and then z here. So I'm going to have something like that. Okay. The question tells us that the measure of angle xyz, this angle right here, that's 149.1. Okay. So this is obviously drawn not to scale because I mean I'll draw it to scale just for y'all. It'll be something like this because the arc it encompasses will be a lot more. 149.1 y. Let's see. Okay. So what we have to realize is that this angle that they give us, angle XYZ, that is half of the total length of this arc. So arc YZ, which is basically the major arc in this scenario, a major arc YZ. That is basically double of the I think the inscribed. I think that's what they call it. The inscribed angle within the circle. So basically, we can find the entire length of this arc by just doing 2 times 149.1. So that means this entire thing is 298.2. And then the question asks us what the measure of x, y, and yz. So it's basically asking us this and this. And if you notice, that is just the remainder of 360 minus the major arc that we found. So if we just do 360 minus that, we get 61.8. So that is our correct answer to this question. Okay, let's move on to question 21 from another person's exam. So this question, what we're going to do is let's first visualize what it looks like. So we have a circle. I don't want that small a circle. We have a circle with the center at 2,9. So we have a center right here. That's 2,9. Okay. Line T is tangent to the circle at the point A, -4. So what I notice here is that the y value is -4. So I'm gonna have my point of tangency somewhere down here, which is the point A, -4, where A is a constant. The slope of line T is 6/5. So the line T is tangent to the circle. So that means we have a tangent line, basically, something like this. And this is line T. And the slope of that line is 6/5. And the question asks us for what the value of A is. So this question is really easy once you realize that you need to draw another line that goes through the center of the circle and goes through the point of tangency. So if I do, oh, this is hard. If I do something like this, okay, just pretend that goes through the center of the circle right there, okay? I'm able to find the slope of this line by taking the negative reciprocal of the slope because a tangent line creates a 90-degree angle with the circle itself. So if I just create a line going through the center, then that means line T and this line right here, these are going to be perpendicular lines. So that means if this slope is 6/5, this slope will be -5/6. And since we have a point going through that slope, we're able to find the equation of this line. So if I do y minus y1 is equal to mx minus x1, this is point slope form. Let me plug in the point that goes through the line. So that's 9. The y value is 9. I'm plugging in the center, by the way. x1 is 2. The slope is -5/6. Okay, and this is basically going. Let me make this a little bit bigger. This is the equation of this line right here. So this line, that's the one represented in the Desmos graph right here. And we know that this line intersects at the point A, -4. So if I just plot y is equal to -4, I'm going to see what the value of a is. That's basically my x value of the intersection point. So if I just do 17.6, turn that into a fraction, I get 88.5. So D is my correct answer to this question. Okay, let's take a look at question 10. So question 10 is just a relatively easy slider question. So it says, in the given equation, b is an integer. The equation has no real solutions. What is the least possible value of b? So if I do negative x squared plus bx minus 49 and create a slider for b, I'm going to see that my graph is all the way down here. Okay, so let's make my bounds 20 to -20, and let's make my step 1 to 4 as integers. So now what I'm going to do is I'm just going to test a bunch of values. I'm going to drag my slider, and you're going to see that the quadratic slowly approaches the x-axis, and when b is equal to 14, it touches the x-axis. So right now, b must be less than 14 for it to satisfy the no real solutions aspect. But now let me see what happens when I make b negative. So if I decrease b, it's going to head back towards where it was earlier, and then it'll slowly start heading back towards the x-axis. And you're going to see at -14, there's also one solution. So if I want there to be no real solutions, I need I need b to fall in between -14 and 14. And then it asks us what the least possible value of b is. So what is the least number, least possible number in this inequality that satisfies the value of b? And that value is going to be -13 because you can't include -14, and -13 is the least possible value of b that satisfies this inequality right here. So -13 is our answer to this question. Okay, let's take a look at our last two questions, which looks like a beast of a question. I've actually never seen this question before. So let's get into it. So the figure shows a triangular tetrahedron. Let me make this smaller. A triangular tetrahedron, a three-dimensional figure with four triangular faces, three of which are right triangles. A chemistry professor uses triangular tetrahedrons to create a large-scale model of various carbon-based molecules. The base of one of these tetrahedrons is an isosceles right triangle whose legs each have a length of 14 inches. The height of the tetrahedron is 15 inches. Which of the following is closest to the volume of the tetrahedron in pints? Okay, so this is actually a beast of a question. You need to do dimensional analysis, you need to find volume, you need to use area of triangles, a bunch of stuff. Okay, so luckily they give you what the volume of a triangular tetrahedron is right here. 1/3 SH, where S is the area of its base and H is its height. So let's first determine what S is, because I mean we have the height. The height is 15 inches, that's given in the problem. But let's find what S is. S is the area of the base, and we said that the base of the tetrahedron is an isosceles right triangle. We can represent the area of an isosceles right triangle as 1/2 base times height. Base times, or 1/2 s squared. I'll do that. 1/2 s squared, because we're basically this is the base, or I mean this is the base and this is the height. I mean depending which way you look at it. This is the base, this is the height, but it doesn't matter because these are isosceles triangles, so the base and height are the exact same number. And we know that they have a length of 14. So we can say that s, that's equal to 1/2 s squared, or 1/2 14 squared. Let me put parentheses around that. So S is 98, okay? And then I can calculate the volume by doing V. That's 1/3 S, which is 98, times H, which is 15, given the problem. So the volume of the tetrahedron is 490 inches cubed. So we need to keep track of units now. So the units of the value of S, which is the area of the base, we're doing 1/2 times 14 inches times 14 inches. So inches times inches, that's inches squared. And then if I do inches squared times 15 inches, that's inches cubed. So 490 inches cubed. So let's get into our dimensional analysis now. So if you did chemistry, this should be really easy. So you have 490 inches cubed. Okay, I'm going to do this in Desmos because writing it out takes a while. So what we need to do is we need to find the volume in pints. And the way you make sure that you're going in the correct direction is by canceling out your units. If you cancel out your units, it helps a ton so that you can keep track of what your the true value really is. So 490 inches cubed, and I'm going to multiply. Since I want inches cubed to go away, right? I don't want inches cubed. I want the volume in pints. What I'm going to do is I'm going to put the 57.75 inches cubed in the denominator. And the reason why I'm doing that is because I want the inches cubed to cancel out. So you're going to see, so 57.75 inches cubed, that's 1 quart. So you're going to see that if I multiply, so this is basically a fraction. Inches cubed and inches cubed here will cancel out because one's in numerator, one's in denominator. And now you're going to see that my units so far, the unit I have my value in is quarts, but I don't want it in quarts, I want it in pints. So then I need to do one more step, ensuring that I'm canceling out the quarts. So if I add 0.5 quarts to the bottom, you're going to see that that's equal to 1 pint. I can't. Okay, so PNT, that's pint. So quart and quart will cancel because one is in the numerator, one's in the denominator. And you're going to see I'm left with my unit as pints. So once you're here, what you have to do is you have to multiply everything that's in the numerator and divide by everything in the denominator. So if I do 490 times 1 times 1, that's just 490. Divide that by 1 times 57.75, so 57.75 times 0.5. I get my value as 16.969696, and that basically rounds to 16.97, which is answer choice A. So that's my correct answer to this question. Okay, let's take a look at the last question here. So basically, it should say in triangle XYZ, AC over K, AC is equal to K, and B over AC, A over C is equal to K, and B over D is equal to K. What is the value of K? Okay, so this question is relatively simple because you have to realize that these are similar triangles. So VYW, that's similar to VXZ. Okay, so what we need to do is we just need to create proportions here. Okay, we need to include A over C or B over D somewhere in order to find the value of K. So if I do A over C, that's going to be equal to 54 over A over C. Oh, my bad. I'll do this way. I can't do that. I'll do A over 54. Okay, because I'm doing this over this. That's equal to the big triangle. That's equal to A plus C over 99, because that's basically the big base. So let me cross multiply. I have A times, I'm gonna write this out here. A times 99, that's equal to A plus, I'll do 54 times A plus C. Okay, now let me divide both sides by A. So I'm gonna isolate 99. I'm gonna say that's equal to 54, and then A plus C divided by, X all these out, divided by A. And then what I'm going to do is I'm going to divide 54 to the left-hand side. So 54 will go over here. So 99 over 54, that's equal to A plus C over A. And what I could do now is I could separate this out into two fractions. I can do 99 over 54, that's equal to A over A plus C over A. So A over A, that's just 1. Right, because that obviously cancels. So what I'm going to do now is I'm going to subtract 1 to this right-hand side to isolate C over A. So if I subtract 1, I'll just type this on the new line. The value of this is 5 over 6. So I know that 5 over 6 is equal to C over A. And we're asked for the value of K, where K is A over C. So if I just take the reciprocal of both sides, I'm going to get that A over C, that's equal to 6 over 5. So 6 over 5 is the value of K, which is my correct answer to this question. Okay, we're done with all 12 questions, and I hope you guys enjoyed this video. If you guys have any feedback on the way you guys want me to solve questions, or any preferences on like the format or anything, let me know. I'll try and create better long form videos because it's my first one for you guys. And if you guys enjoyed, please like, please subscribe, comment, go follow my other socials, TikTok, and I'm planning on posting on Insta so that I could garner a larger fan base. But yeah, hope you guys enjoyed the video, and I'll probably upload another one for the August SAT, or I'll probably upload a Blue Book walkthrough through an exam. just so that you guys can see how the Excel math solves a math module and various math questions. But thank you guys and have a good night.